Here is an example of a problem where it shows that it's actually very important if you're doing an English test, English math test, that your English is also quite good. You see, sometimes when you do math problems that are written in English, you can look at the problem and find the 3 or 4 numbers and guess what you're supposed to do with the numbers, even if you don't completely understand every word. On this problem, there are actually many more numbers than you need to use. So it becomes a reading problem and a math problem. Actually, I wanted to give this example because, first of all, there are many interesting and important exams that you might want to take if you wanted to study in the United States, whether it be the SAT, or in this case, if you wanted to play with AMC 8 problems. On this question, let's try to read it slowly. You go on a trip to meet your 72-year-old grandparents who live 70 miles away along Interstate 84. So many numbers. This is just how old the grandparents are. This is how far away they live. This number is almost definitely not important, but I'm sharing with you some of the story of the United States. In the United States, the highways have numbers, and these are interstate highways that go between many of the states. The numbers are usually 2-digit numbers like this. Probably not important for this question. Maybe I will just already say, probably not important. On the way there, your average speed is 42 miles per hour. If you're reading a math problem and you see this kind of information, it's probably quite important. Average speed is 42 miles per hour. Okay? Actually, at this point, you may be thinking, this looks like a problem about traveling, at which point the 70 miles away are also important. Okay? There, you watch the TV show 60 Minutes. Oh, well, if it's a problem about speeds and distances, then probably this is also important, right? Because it's a time, 60 minutes. Well, no. You have to look carefully. There are some quotation marks here, which means that it's a name of a TV show. I can tell you, actually, what this TV show is. It's a news show run by CBS, which is one of the major American broadcasters. And this show is where they interview a famous person and have a conversation for 60 minutes. That's why it's called this. But because it has quotes, it's also probably not important. It's just the name of a TV show. On channel 3, this is just the number of the channel that you're watching. Probably not important. On the way back, there is traffic, and your average speed is 30 miles per hour. Now that looks like it's probably important. So now there's an average speed 30 miles per hour. What is your average speed overall during the drive? Aha. So this is the math problem. Average speed overall. So I'm just showing how if you are looking at a problem in a language that you don't normally use, it's useful to think about what's important and what's not important. But of course, we'll also do some math. Now, we also found out that the 72-year-old grandparents, also, the age is not important. So my whole problem is 70 miles away, and I am going the same distance in 2 directions, going there and coming back. 2 speeds. Find the average speed. This is a normal question at this point. Distance, 70 miles. When you go one way, your average speed is 42. When you go the other way, your average speed is 30. So then how do you do these questions? If I want to know the average speed overall, I use distance, rate, and time. And if I'm doing this, let's remember, we always know that distance equals rate times the time. And so if I want to know how many hours it took, I just have to divide. So this side will just be 70 over 42 hours. And this one will be 70 over 30 hours. I want to know the average speed overall, so I should probably add them up and do some division. How do you do that? Let's do it on the next screen. If I have 70 over 42, I could simplify this by dividing top and bottom by 7, and I will get 10 over 6. If I want to take out another factor of 2, I have 5 over 3 hours. On the other hand, if I have 70 over 30, this is easy to simplify. This is equal to 7 over 3 hours. Oh, what a nice number. Added all together, then I have 12 over 3, which is 4 hours. If I have 4 hours, and my total distance that I traveled was 70 times 2, there and back, then my average speed is equal to 70 times 2 miles divided by 4 hours, which simplifies very nicely. The 2, 4 gives me a 2 down here. Divide, I get 35 miles per hour. Usually in English, we actually write mph, which stands for miles per hour. This is one way to do the problem. It's actually quite nice that the numbers all work out, and you can do it this way. I'll say, though, there's another way, of course, to do this question. And the other way is actually even more important when one of your numbers is not so nice. Imagine, for example, that it wasn't 70 miles away. Let me try changing the number a little bit to give you something much worse. What if the distance that they lived away was not 70, but something else, like 71? If you have 71 now, what happens to all your calculations? Now, this becomes 71. This becomes 71. And this becomes 71. If all of those are 71, actually you can't simplify anything at all. Ironically, that's actually a good thing. Let me write down what you'd have if instead of these 70s you had 71. You'd have 71 over 42 hours for the time that it took for you to go there. 71 over 42 to go there. And you'd have 71 over 30 hours for the time it took to go back. And now I can't actually simplify anything. But if I add the two together, then I'll get 71 over 42 plus 71 over 30 hours total. Then what's my average speed? Well, then my average speed is equal to, remember, it was the total distance times 2 over the total time. So I get 71 times 2 total distance divided by total time, which was 71 over 42 plus 71 over 30. These are hours. What happens to the 71? Actually, there's a 71 on top and on the bottom. It's beautiful. Actually, the 71 is also irrelevant. You can cancel it on both top and bottom. What this actually means is, go back to the problem. I told you what was the important information in this. Actually, whenever you're doing a problem where you're going somewhere and coming back, and you're going the same distance, and there are two average speeds, actually, you don't even need to know how far you're going. So what I'm showing is that first, when we read the English, we found out some things that you obviously don't need. You obviously don't need the name of the TV show. The mathematics that's deep inside here is that you also don't need to know how far away it is, because it happens to be a kind of problem where you go there and back. Actually, that's because it's related to a deeper mathematical concept. This, when the 71s all cancel, if I write down what I actually have, I have 2 divided by 1 over 42 plus 1 over 30. Now I'm going to do something to this fraction, which looks like a very bad idea at first. I'm going to divide the top and the bottom by 2. And I get 1 divided by 1 over 42 plus 1 over 30 divided by 2. This looks like a terrible idea because I took something and made it worse. Except that actually, when you look at what this means, here, the 42 and 30 are the two numbers that were in the problem of the two average speeds. I took their reciprocals, which means 1 over it. I took the reciprocals of both. I took the average of those reciprocals. And then I took the reciprocal again. We maybe have seen this if you have seen some of the other classes that I teach. I like to show this concept, and so I'm going to write it down again in English, what I just did here. What we just did is we took the reciprocals of 30 and 42. And then I took their average. And then I took their reciprocal of the answer. This procedure has a name. This procedure is called the harmonic mean. Of 30 and 42. If I didn't take the reciprocals and I just took the numbers and took their average, that would be called the arithmetic mean. This is called the harmonic mean. And so whenever you actually are doing this go there and come back type of problem, the answer is always just the harmonic mean of the two speeds, which is simply taking the reciprocals, averaging, and the reciprocal of the answer. I'm not going to go deeper into this particular thing because that's actually a topic of an entire lesson. But I wanted to use this example of an AMC 8 problem to show the value of reading carefully a math problem, of reading a math problem very carefully to have that experience of pulling the important numbers out. And then to also find out that sometimes the mathematics itself makes another one of the numbers also unimportant.